Good morning. Thank you very much, Drew. I want to thank our hosts here at Esri for holding this Ocean and Atmosphere Forum. It's no accident that the National Oceanic and Atmospheric Administration is providing the keynote, and I'm happy to be here. Thanks for the invitation, Guy. Really appreciate that. And as Drew mentioned, I have a geospatial expert up here to help me go through my first story map. So this will be the first presentation I've given in that format. And I did want to recognize her colleague, Randy Warren, as well. Both of them provided a lot of education to me over the last couple of weeks, especially on what a story map can do. So first, I love maps. I always have. The first map I remember as a kid was doing a puzzle of the United States. Beyond that, I think I got a map one Christmas of my town, black and white line drawings. Ever since then, I've really enjoyed that. And my wife and I have tried to convey that to our kids. And it's, so this is my 4-year-old daughter doing a puzzle of the United States. And it's more than just geography. It's more than just problem solving. We use this to tell her, hey, this is where your grandparents live. She knows where I am today. She knows I'm in California. And of course, those important things like Disney World's in Florida. She knows that as well. So there's stories, there's memories that are part of maps. And that's part of my life and actually what attracted me to NOAA in the first place. So when starting to put this together, I said, well, what would be the base map that I would provide my story in? And this is what first came to mind. My wife bought me a little scratch-off map, said, show me where you've been, and we've kept that up. And so this shows all the places that have been scratched off, where I've worked, played, lived, mainly work. You can't see it on this detail, but I just haven't made it to Vermont yet. That's my last state, and then I'll have done the United States. But there's a lot missing for me in this story. So let me show you a different map. This map shows all the track lines of my ships, during my NOAA Corps career. And you can see from the North Atlantic to Iceland, all the way down to the massive icebergs off the Antarctic ice shelf in the South Atlantic, through the Straits of Magellan, a few times through the Panama Canal, working across the equatorial Pacific, a lot of times in the coast, the Gulf of Mexico, East Coast, West Coast. But here's where I'd like to transfer this to being about me and being about NOAA. Okay, back one. Sorry.
Back, sorry.
There we go. All those track lines represent ships that carried out NOAA's mission to collect data. Whether it's the deep sea oceanography that we do every decade, to fisheries research, to ocean exploration, to installing, maintaining buoys in the Central Pacific especially. I can remember each one of those track lines. My first one was from Miami, going through the Panama Canal, and recovering a towel buoy, putting the new one in, and continuing, going across the equator for my very first time, all the way up into San Diego for my very first trip. I'll save for my last trip for later. But think of this as what NOAA is doing in all these areas, and this was just the ships I was on, not the whole fleet, not aircraft, not satellites, collecting data to support the nation and the planet. Next. Here's a photo of all the ships that I served on during my career. I'm going to highlight two. The one on the upper left is the Malcolm Baldrige, former Secretary of Commerce. When I showed up on that ship, I was eager, ready to go, just out of college. I said, yeah, can I go to dive training? Nope. How about emergency management training? Emergency medical technician training? I said, nope, we got something better for you. We're sending you off to data school. And turns out that was probably the best thing they ever did. I went to get training on our scientific computer system, the system that would collect all the data for the ship, and it was my job on that first ship as an ensign to make sure that we programmed it in right, we saved it. At the end of a project, I would give it to the chief scientist, I'd save a copy for the ship, and then I'd mail one off to the National Centers for Environmental Information. Turns out that wasn't the end of that part of my role, since that's where I work today. And then the one to the right was my first command, the NOAA ship Okeanos Explorer. What I'm most proud of for that ship and realizing the goals of that program was that all of the data collected on that ship are preserved, and there's a very close relationship with the National Centers for Environmental Information to make sure everything that's collected on there is preserved for future use. Next. During your career, you do get to go to shore duty, so you're not spending the whole time at sea. My first opportunity to do this was at the Northwest River Forecast Center in Portland, Oregon. I did not have GIS. I got to buy topographic maps, stitch them together, plot out all the in situ, precip, temperature, radar sites, and where the river gauges were, draw the basin boundaries, this is all manual, and then download data from the National Centers for Environmental Information to do the calibration of river watersheds to support that. I did take my first GIS class at grad school at that time as well, but I'm proud to see today that everything we do really is represented in a geospatial way, as you can see, the 120-day forecasts just from the other day. My next stop along the way was to work in Mississippi, Pascagoula, Mississippi, on a couple of ships, the Oregon II and the Gordon Gunter, where we actually did quite a bit of projects to evaluate stocks, fishery stocks, whether it be shrimp, sharks, striped bass, you name it, larval studies, protected species. How many people know there are orcas in the Gulf of Mexico? Seen them. Pretty amazing. And now, initially when I was doing this, we were actually applying statistical models, providing that to the fisheries management councils for what they do. Today, they have a whole slew of tools, analysis, geospatial, even ecosystem-based assessments on which they use to base their judgment on how they would manage fisheries. So this is the Ocean and Atmosphere Forum. My next stop along the way was in Miami, where I worked at the Atlantic Oceanographic and Meteorological Laboratory, one division of which is the Hurricane Research Division. And they actually do research where they staff the P3s, piloted by NOAA Corps officers as well. You won't get me up there. Being at sea is enough. But this just shows an animation of the collection of data in and around a storm that we use to improve our forecasts. Again, data collection, not just on the ocean or in situ, but in the air, in the atmosphere. In this case, an adaptive sampling capability. In this collage, you see a lot of different offices in NOAA. The mission of NOAA actually spans from the surface of the sun, space weather, all the way to the depths of the ocean. And I could spout off the numbers of people in NOAA and the budget of NOAA, but what I really wanted to focus on was the geospatial aspects. Right now, we have more than 3,400 users that are registered to use the NOAA geospatial platform. We have more than 900 public map stories that we use. And we're partnering with Esri to provide more than 100 data sets, data layers, that are in the Living Atlas. So those are some of the things we're doing as part of our mission. And the 3,400 for reference is it's better than 1 in 4. Better than 1 in 4 NOAA are contributing and part of this. So here's the surprise part. We'll see where we stand. Doesn't look like we're doing a dive. So, Dr. Earl,
gotcha.
For those who...
so don't listen to it.
Oh, it looks like they're actually going through the checklist right now for an ROV dive. So this is live streaming from the Oceanus Explorer. So that's probably what you're going to hear in the background. But Dr. Earl was on the President's Panel for Ocean Exploration 20 years ago. And I'm grateful for your effort. Hence, I got to be the first captain of this ship and was particularly enamored with one of the goals, basically to collect data so that those not yet born could solve problems not yet known at the time of the exploration. The only thing I would modify that with today is that we're using it a little faster than we thought, that information that we gather, essentially. But one of the revolutionary technologies that we're using is telepresence. So we actually see what's going on. We don't have to wait. At the commissioning of the Oceanus Explorer, Dr. Ballard read off the instructions from Thomas Jefferson to Lewis and Clark for their expedition, what to gather, how to do it, very intricate details that the president said. And we tried to emulate that a little bit. Mapping the seafloor, sending an ROV down to dive, mainly digital, but then sending it back so people could see it a little faster. They didn't have to wait several years before getting that access to the data. And then, like I mentioned earlier, storing it all at the National Centers for Environmental Information. After that experience, I actually went to work in Boulder for the National Centers for Environmental Information and served also as a liaison to U.S. Northern Command. Part of whose responsibility is to support FEMA and other federal agencies when the task becomes too big. It was in that role that I was actually asked to serve down at the Deepwater Horizon Incident Command in New Orleans. And I showed up as the head of the subsurface monitoring unit. This was a massive spill for months on end. So there was a lot of subsurface sampling that was done. And it was all hands on deck. It was public sector, private. Obviously, they were working to help clean it up. Nonprofits, a whole slew of individuals, ships were out there sampling. The issue was there was no common terminology for how they were sampling, how they were naming their sites. So we're about to get a whole bunch of data back, and how are we going to analyze it? I had a GIS team working for me. Perhaps some of them are in the room today. That would be great. I'd have to thank them again. But I worked with them, and we actually put together a Rosetta Stone to basically say, here's the official name for each of those sites. So that when we analyzed all the data that came back for that response effort, that you could say, okay, this was same site, same data, we can compare it. Tremendous real-time, high-pressure situation where the admiral who was in charge of the incident command was asking for geospatial information about what was going on, what do we need to do, where do I need to mobilize. How do I know you sampled all the sites? Are you keeping track? Some of those simple things we were able to do, and it was, with the GIS team there on site, we were able to do it. So my last ship, command of the Ronald H Brown, the flagship, NOAA's only global class. I actually got on board when we had a challenge with maintaining the tower array in the Pacific. So if you recall, my first trip was to install, maintain the tower array. My last ship, that was the key challenge we faced. And we actually, during the course of my tour on that ship, we were able to restore the tower array to its functional order, to its operating capability. And this is a very, very simplistic map of where those are so that the folks on the ship knew what the progress we were making. This went to Weather Service headquarters. They were watching it. NOAA Research headquarters were, and it was even going all the way up to Congress to say, where's the status of this array? Something that's key for us maintaining a look at the planet. At that time, I took off the uniform, I retired, and assumed a senior executive role, and my horizons expanded even more in NOAA. In particular, I had to start taking in this satellite perspective for observations for weather, climate, et cetera, the oceans. It's a tremendous breadth of experience when I'd really focused most of my career on ships and in situ, radar, aircraft, and how all of a sudden satellites. But it makes a lot of sense. In order to sample the entire planet within a relatively short time, you got to have satellites to do it. In addition, and I think you'll hear from my colleague, Dr. Alexander, back. It's not just the leveraging that I learned in the Weather Service of foreign, but also commercial sector observations. As the head of the observation portfolio, I was actually buying a lot of commercial observations, whether they be mesonet, lightning, et cetera. And we're doing pilots and looking at this in the satellite realm as well to expand our network. So it's really, leveraging. And actually, that's how the head of the Weather Service did it. They said, Joe, in your job description, it's not just what we own, it's what we leverage. And I said, the leveraging is going to be more than what we own. And he's like, absolutely right. Satellites, private sector, public sector, foreign, all of it. In addition, part of the mission for the Weather Service, and this was realized earlier in this past decade, is not just to issue the forecast, but it's really about a weather-ready nation. So it's a society that's resilient and informed. And that's not something we can do alone. It really takes a full enterprise effort to realize. I think that's some of what we got today in many ways. So now I find myself, since the beginning of the year, as the deputy at the National Centers for Environmental Information. We're based at multiple locations across the country. I'm in Asheville, North Carolina. We have a huge environmental archive, like I said, from the surface of the sun all the way to the depths of the ocean. Right now, that archive is over 30 petabytes, most of it compressed, and it's growing today, or every 3 months, we add another petabyte. So it's going like this, pretty much going vertical as far as the storage goes. We serve up over 10 petabytes of data every year online to consumers, users for that. And this is, we basically use that, so we do that archive service, and then we have a science component that looks at, well, how do we analyze that to see the historical trends, retrospective looks with that data. So we produce the $1 billion disaster reports, the annual climate reports. We house the technical support unit for the National Climate Assessment. When you see something that a news release that this is the warmest September of all time, that's where you're getting that trusted information. We're comparing it to our historical data. We do other things like maintain all the bathymetry that is gathered by NOAA, all the other sets. So, and we try to provide viewers or GIS tools for people to access. That's one of our challenges. I'll get to that a little bit later, but how do we access all of that data? So I think we've caught up through my career to where I am, and I wanted to talk a little bit about what the priorities are today for NOAA. So we have an animation, kind of a 3D map animation of what the Ocean Exploration Program is doing. But it's not just exploration. It's actually addressing needs for extreme weather, tsunami, as well as blue economy and commercial fisheries off of Puerto Rico. So we're going to play that, and this is kind of, they use this for the review of that program this year, but it kind of gives you a sense of what they're trying to do and then how it feeds into some of our other priorities.
Just as with the findings of explorers and naturalists of old, the full application of data gathered through exploration today can't be fully known at the time it's collected. The data collected by NOAA ship Okeanos Explorer and its remotely operated vehicles offer a window into our world's last great frontier, illuminating views of our ocean both as a microcosm, as well as providing big picture perspectives, like this bathymetric map. The data points used to create this map were collected by the Okeanos Explorer during Oceano Profundo, an expedition around Puerto Rico which took place in November 2018. The purple line shows the track the Okeanos took while collecting the bathymetry data that was eventually used to create the multicolored hillshade layer below. The vertical navy blue line represents the ROV dive track for the 10th dive of the expedition, which took the ROVs into the depths of Mona Canyon. This dive explored the geologic instability in and around the Puerto Rico Trench. It's thought that a landslide in the submarine canyon may have been the source of a tsunami which struck the island following the 1918 San Fermin earthquake, destroying much of the island's infrastructure. Exploration like this helps scientists better understand deep-sea geohazards and informs models of tsunamigenic events. Better modeling, which is improved by ground truthing, leads to better predictions concerning future hazard events. But it's not just academics who contribute to, use, and benefit from Okeanos data. During a later dive on the same expedition, local fishers were vital in suggesting dive sites of potential importance for this queen snapper and contributing information during the dive live streams. Video observations taken during the dive expanded the known depth range of the species by more than 75 meters. Although the queen snapper is a commercially important resource in Puerto Rico, very little is known about its behavior. Information gained through underwater video and other Okeanos data sources can help fisheries managers in their work to sustain healthy fish stocks and support local economies. Baseline characterization of deep-sea biological diversity, geography, and habitats provide insight about the past, present, and future conditions of these essential natural resources. The systematic collection of this data fills critical gaps in the basic understanding of U.S. deep waters and the seafloor, and allows decision makers to make informed choices regarding these resources. The images, specimens, and myriad other data points collected by the Okeanos Explorer are rare insights, unattainable through other means, into a largely inaccessible environment, yet one that is intricately tied to the health and prosperity of our nation.
So if you look at this map, this is in the NOAA Geo platform using data layers from the Living Atlas to highlight fires as well as air quality in the California area. And you can actually back out and show folks what we can see and how widespread that is. Not as much as Dawn showed around the world, but still according to the same data, and trying to provide this for decision makers on where do they deploy. I've seen this elsewhere in the United States, where we in NOAA deploy an incident meteorologist to help support the incident command for one of these fires. And they get the data right there and are able to inform and convey even the nuances for when say, gust fronts are going to pass, and we need to be watching out for a shift in where that fire is going to go so we can actually protect those firefighters as well. So a lot of this information is critical to protecting those lives as they try and protect our properties. So the video highlighted some of our fish stocks, one in particular by Puerto Rico, but the blue economy is actually a more expansive initiative in NOAA. In the weather enterprise, there's a tremendous amount of the economy that's based on that. The same is true for the blue economy. Whether it be the shipping that comes into our nation, hence why the NOAA was founded, originally a survey of the coast by Thomas Jefferson, to basically make sure that commerce could come into our nation. The ports, that was actually showed as well. I think we showed Rotterdam, but we do that here in the United States as well to better support commerce coming into the nation. Every few feet is a little bit more that freighters, tankers can be laden as they come in or leave the United States. More and more we're watching harmful algal blooms and their effects. There's a season up on Lake Erie that we monitor and issue forecasts for now in NOAA to make sure that the city of Toledo has good drinking water, or they have to take the measures they need to. But it's becoming more and more critical around the entire coast and affecting quite a bit of tourism as well as just general health near the coast. Next. We mentioned how big the data is. One of our initiatives to try and handle that is the Big Data Project. And you're seeing the National Radar Mosaic. That's one of our big success stories of that. It was over 300 terabytes of data that had been stored, but really couldn't be accessed by folks. Once that was uploaded in the Big Data Project, folks were able to access it. They're able to analyze it using research tools. And then this is the most downloaded layer, besides the base maps, in the Living Atlas as well, over 10,000 per day. To put it in context, the peak for a layer on the tropical cyclone, so during Hurricane Dorian, was basically 12,000 downloads on a peak day. So it's getting quite a bit of usage to get this layer through that. And this area is key for us to be able to provide access to those vast volumes of data that we have. Next. So looking at tomorrow, what are the challenges? I mentioned NCEI, the National Centers for Environmental Information, produces the $1 Billion Disasters Report. Well, this is a look at this historically. And notice the trend. It's not shrinking. It's only becoming more important for us to be able to maintain our environment so that folks understand it, and then they can make informed decisions about what they do. Some of our challenges, and this came up earlier, is we do need more data. There's a lot of the sea floor that hasn't been mapped, for example. In particular, one of my first cruises on the Okeanos Explorer, we went out to chart an area off the west coast, not even 100 miles off the coast, found a geological formation that was better than a kilometer high off the bottom, more than a kilometer wide. There's a lot of those that we're finding because most of that map is satellite gravity measurements versus the much higher resolution. So one is, do we have the data? The second is, with the data we have, can we access and understand it? Can we use it? And this, we have a lot of data saved, and it's saved according to, in general, a model of a principal investigator stores it, puts it in a big tar ball, we put it in the archive with the metadata, but it's hard to get out to examine together. So we have to do that so that we can look at it. But this also applies in the areas of like weather modeling. We get a tremendous amount of data from our satellites, but we only actually look at a small portion of that to feed it in the models because it's a measure of time. We have to run the models fast enough to inform decision makers. So our challenge is to have increased capability to do that and then get the right data in there to improve those. So it's multiple. And then one I didn't add on the slide, but I should have, and it was brought up earlier by Dawn, was being the trusted data source as well. So all the stuff that's out there, is it the peer-reviewed, trusted data that you're relying upon for your decisions as you go forward as well? So some of the answers to this, to getting more data, is unmanned systems, crowdsourcing. We don't have to do everything. Partnering. Sail drone was brought up. Using the private sector, leveraging their capabilities for doing this versus the traditional, we do it all by ourselves. It's really a partnership across everyone to make sure that we do this. But then again, this adds to the diversity and the volume of data. So how do you analyze it? This is where some other transformative technologies are coming in. The cloud, NOAA is doing a lot of pilots in the cloud right now to see what could be the potential for us to provide better access. What are our capabilities for artificial intelligence, machine learning to take advantage of that? What you're seeing here is some algorithm development. We had an issue on the GO-17 satellite after launch. The cooling system for the imager wasn't quite working. So what are some ways, and there was a whole team came together, made sure that we did everything we could to make that work as well as it could, but then also to look at AI-based image correction algorithms to fill in some of the gaps. We've got that imager up to 97% capability for everything it does, particularly for monitoring fires at this point over the West Coast. So those things are all coming up, and then if you add in some things like quantum computing, to be able to process things faster in different ways, these have the potential to solve some of those challenges that I brought up. Finally, I wanted to leave you with our aspiration. This is what we're working towards at the National Centers for Environmental Information and our parent organization, NESDIS. Basically, a truly integrated digital understanding. It's not just about the ones and zeros in the data, but how do we actually understand the planet? We put everything together. And then, because things are changing, they're changing quickly. But the other part is that we want to leverage our capabilities and our partners. That's all of you in the room. That's many others. The geospatial capabilities to realize the value and make the decisions with the data to inform folks to do that is really what we aspire to and what we're working towards for the future to solve those problems. And with that, I will say thank you very much for this opportunity to be here. This is me having a little fun when I was a younger officer. I don't get to do this anymore, but and I should give credit to Tony Perry who took the photo versus posing in the water. But thank you very much for being here and for exploring some of these solutions that we need this week. Thank you.